A logarithmic function is the inverse of an exponential function. The graph shows y equals 10 to the x power, in orange, and its inverse, y equals log of x, in blue. Recall that the graphs of inverse functions are reflections of each other across the line y equals x. You can graph y equals log base b of x as the inverse of y equals b to the x power. Note the points 0, 1 and 1, 10 are on the graph of y equals 10 to the x power. And their inverses, the points 1, 0 and 10, 1, are on the graph of y equals log of x. Note the diagonal line y equals x, shown here in purple, making it easier to see that our two graphs are reflections of one another across the line y equals x. Problem 4. Graphing a logarithmic function. What is the graph of y equals log base 3 of x? Describe the domain and range, and identify the y-intercept and the asymptote. First consider y equals log base 3 of x is the inverse of y equals 3 to the x power, a function we may be more comfortable with graphing. So in step 1, we'll graph y equals 3 to the x power. It's shown here in orange. Step 2, reflecting across the line y equals x, shown in purple, produces the inverse of y equals 3 to the x power. Step 3, we'll choose a few points on y equals 3 to the x power and reverse their coordinates. X becomes y becomes x. We'll plot these new points and graph y equals log base 3 of x, the inverse of y equals 3 to the x power. The domain is x is greater than 0. The range is all real numbers. There is no y-intercept. The vertical asymptote is the y-axis, or the line x equals 0. Your turn, part A. What is the graph of y equals log base 4 of x? Describe the domain, range, y-intercept, and asymptotes. And part B, a reasoning item. Suppose that you use the following table to help you graph y equals log base 2 of x. Recall that if y equals log base 2 of x, then 2 to the y power equals x. Copy and complete the table. Explain your answers.